Hello everyone, my name is Jawad. Today I'm going to have a presentation on wildfire evacuation management under evacuees compliance uncertainty. This is a joint work with my colleague Professor Remy Kim. In this presentation, I will go through a background, problem identification, research objectives and context, progress which has been so far, and I wrap up the presentation with a summary of the research. According to statistics, approximately 8,000 wildfires occur each year in Canada. Wildfire seasons are beginning earlier and lasting longer. Fires are getting larger, more frequent and intense, impacting wildlife and Canadian communities. A major problem arises at wildland and urban interface areas where homes or other vulnerable community structures meet with wildland views. While the common practice is to evacuate people from the areas at risk, a large percentage of human fatalities and risk and cost are attributed to poor evacuation operations. This is because the evacuation management is a multifaceted and interdependent problem that involves several actors and factors. As we can see, evacuation problem has all sorts of issues with respect to information dissemination, issues of potentially controlling, guiding, and giving directions to people, and also issues of evacuees compliance and decision makers' attitudes towards risk. These issues, which are related to the evacuation and emergency movement of the people, as we can see, are the problems where the autonomous systems can be potentially utilized to improve the evacuation outcome. To come up with a solution to improve the evacuation operations with the possibility of utilizing the autonomous systems, in this study, we aim to examine whether and how evacuees compliance behavior affects the evacuation outcome, and then how to best issue the evacuation instructions for better utilization of the resources while accounting for evacuees compliance and decision makers' risk attitude, and considering other site constraints related to supply and demand and network capacity. With respect to our first objective to examine the effects of evacuees compliance, we identified and defined different circumstances with regard to the evacuees compliance behavior and decision makers' assumptions and understanding of the compliance behavior. We then developed several numerical tests with respect to the evacuation operations under the identified circumstance to see how significant the effect of compliance can be on the outcome of the evacuation under each circumstance. Our observation shows that under a certain compliance level, having information about the compliance can make a huge difference in evacuation planning, and therefore the compliance rate needs to be taken into account in order to improve the evacuation operations. Having our findings from the first objective, we then move forward to the second objective, which is developing a solution to achieve near optimal evacuation instructions. Given the uncertainties involved in the input parameters such as the compliance rate and the compliance distribution, we chose a stochastic optimization modeling technique. The proposed model finds solutions for instructing the decisions of the departure route choice and destination choice for the evacuees. With the objective of minimizing the expected travel costs, the proposed model also considers uncertainties regarding evacuees' response or their compliance behavior and decision makers' risk attitude, and then performs the evacuation planning based on the certain percentage of the worst possible outcomes of the evacuation as a risk measure which is provided by the decision makers. Moreover, the proposed model includes site constraints with regards to the roadway and network capacity and destination capacities. Here is our preliminary results from the proposed model. Our observation is that a reactive solution to compliance rate, even under uncertainty, can have better performance and provide more understanding about the magnitude of the possible outcomes compared to the traditional methods, which do not include any risk measure. In future, we are going to have further simulations for different networks and examine the performance of the obtained solutions and perform sensitivity analysis regarding the input parameters. The prospective contribution of this work will be developing a new optimization model which accounts for practical issues such as compliance of the evacuees, risk attitudes of the decision makers, and congestion issues during the evacuation. We hope to drive managerial insights and implications regarding the compliance issues for the improvement of the evacuation operations. Thank you for listening to this presentation, and let me know if you have any questions.